Hello everyone, I'm going to build some series and parallel circuits using the kit I've got here. I've got some filament lamps, I'll probably only use 2 for this video, and I've got a multimeter. And I just want to show you the laws that govern circuits. And we can think more qualitatively as well without getting too deep into measurement and calculation. So you'll notice that I've got this bulb here, connected already, the simplest circuit you could imagine. Filament lamp connected to a power supply. Now, let's just recap. Multimeters can measure both voltage and current depending on where the control is, the dial, the knob. So if I turn this to the 10 amp setting and place it in series with this lamp using the correct terminals, which in this case is the top one and the bottom one, I'll measure the current through that bulb. And it is minus 2.8 amps. Now the minus sign just is a product of which way the current's going through this multimeter. If I turn these round or switch them, get a positive answer. Let's not worry about the sign, let's just worry about the size of it. 0.29 amps flowing through this bulb. So telling us the rate of flow of charge through the bulb. 0.29 coulombs per second. Now, I want you to think to yourself, what is going to happen if I add another bulb in series? So, pause the video if you want, have a think, and then what I'll do, keeping the ammeter in the circuit, I'm going to add this bulb in series. You might have guessed the bulbs are dimmer, hopefully you can see that. The current is 0.20, so the current has gone down as well. You might like to think about why that is. What have I done to the circuit which has brought the current down? While I've got the ammeter, I can show you another thing about series circuits, which is to do with the current throughout the circuit. So we just measured it here, and it was 0.20. What, however, if I move the ammeter between the two bulbs, what current are we going to measure then? Well, if you remember from your previous study, we should expect, well, it's 0.19, but you often find there's a bit of fluctuation in the reading, and these multimeters aren't perfect. So I'm happy with that, 0.20, 0.19. If I put the ammeter at the end, after this, bulb, we get 0.20 as well. Remember, I'm only interested in the size of the current. The minus sign's just about which way I connect the multimeter. So 0.20 thereabouts at every point in the series circuit. So the current in the series loop is the same throughout. Next, voltage. Let me now change the setting on the multimeter so that it is measuring voltage, and I've put it to the setting which means that it will measure 20 volts maximum. Now I put the wires in. I'm going to now remember to measure current, you connect the ammeter in series. You might remember to measure voltage, I want to take the voltmeter terminals or leads and then put them across the component I want to measure the voltage across. Watch this, I'm going to measure the voltage across the power supply first. That gives me 3.97. It's fluctuating, but 3.97. What we'd expect, and you're going to learn about this, and you might have done this last year already, is that voltage across these two components should approximately equal or add to that voltage, 3.97. So let's try the voltage across this bulb first. 1.70. And the voltage across this one, 2.25. So if we add those together, 1.7 plus 2.25 is going to give us 3.95. And you see, my memory's so bad, I've already forgotten what the voltage was here. 3.97. Okay, we're a little bit lower. The total, the sum of the voltage across these two is a little bit lower. You might like to think about why that is. before I say, I'll give you a few seconds. So pause the video, have a think. It's to do with the wires. Now we often ignore the fact the wires have a resistance. Even at A level, we often, when we do calculations, ignore the resistance of the wires. Whereas actually there's an energy loss in the wires, there's a voltage drop across them, hence why there are 0.02 volts unaccounted for. Here's the nice thing about series circuits. What will happen, so you can see I've got two bulbs in parallel. What's going to happen here if I connect a wire, just a wire, nothing else, across this bulb? So now you really need to think. I want you to pause and think about what's going to happen. I'm not going to explain this one. We're just going to observe and you can go away and work it out. So, are you ready? So these two, remember in series, are dimmer than one in parallel, one on its own. Here we go. 3, 2, 1, go. Oh, there's a wonky connection. There we go. So now, hopefully you can see this one is brighter, not as bright as it was when it's on its own, and this one is now off. So let me take that wire out again. So that's two of them in series, not very bright. Let me use a different wire. I see that red one seems to not be working. If I connect the wire across a single bulb, this one goes brighter, this one goes off. What I've actually done is something called short circuit this bulb. Did you expect that would happen? Now go away and try and explain it. Next video, parallel circuits.